Welcome to this explainer. Let's jump right in. Today, we're taking a trip to something so incredibly beautiful, it's literally known as the String of Pearls galaxy. I mean, if you just glance at a standard optical photograph of Caldwell 72, you get this absolutely serene, delicate streak of starlight. It looks peaceful, right? Almost frozen in time. But, well, looks can be incredibly deceiving, because underneath that glowing exterior is a violently disrupted reality that astronomers are really only just starting to wrap their heads around.
Okay, let's dive into this. 6,500,000. That is the staggering distance, in light years, between us and Caldwell 72. It's hanging out in the Sculptor constellation, making it one of the closest galaxy groups just beyond our own local group. But because it sits at this specific, kind of perfect distance, it actually gives astronomers a totally unobstructed, hyper-detailed look at a galaxy outside our immediate neighborhood.
So what exactly is this thing? Caldwell 72, which you might also hear astronomers call NGC 55, was actually discovered way back in 1826 by James Dunlop. It's classified as a Magellanic barred spiral galaxy, meaning it shares a lot of traits, like its shape and brightness, with the Large Magellanic Cloud right near our own Milky Way. But here is the real game changer. We're looking at Caldwell 72 almost completely edge-on. Think of it like a dinner plate. Instead of looking down at the food, we're staring right at the thin edge of the plate. This specific angle turns the galaxy into the ultimate cosmic laboratory because it lets us clearly see the distinct galactic layers, the flat disk and the floating regions above and below it that are normally completely hidden when a galaxy is facing us directly.
And this brilliantly illustrates the core mystery here. On one hand, optical and infrared telescopes give us this beautifully serene scene, bright stellar clusters, active star formation, basically the picture-perfect image of a healthy, functioning galaxy. But when astronomers flip the switch and use ultra-sensitive radio arrays, like the Australia Telescope Compact Array, to map the invisible neutral hydrogen gas, that peaceful illusion just shatters. The radio data reveals this heavily distorted gas field, extreme velocities, and rogue gas clouds just hanging out in deep space. It's essentially a galaxy living a double life. So let's unpack that first phase, the calm optical view. When we peer straight into the thin galactic disk of Caldwell 72, we're looking at a vibrant hub of youth and starlight. Data from the Gemini South and Canada-France-Hawaii telescopes show us that this thin disk is absolutely teeming with recent, highly active star formation. It's not a static picture at all. It's a dynamic living system, constantly churning out brand new stellar life right along its central plane.
To really put that into perspective, let's look at its recent star-forming history. Just 8 million years ago, which is literally a blink of an eye in cosmic time, the brightest red supergiant stars in this galaxy were born. Go back just a tiny bit further to 10 million years, and we see the birth of two massive stellar clusters. And if we look over the last 100 to 200 million years, there's been this vigorous, sustained burst of star formation, creating a huge population of what we call AGB stars. The disk is, for all intents and purposes, an ongoing cosmic nursery.
Now, what's really interesting about this slide is the stark contrast it reveals. Because as we move away from that young, hyperactive thin disk, we enter the extraplanar envelope. That's the region kind of floating above and below the main disk. In the thin disk, we've got very young stars with traits similar to the Large Magellanic Cloud. But looking at the extraplanar envelope, the stars there are way older. We're talking 1 to 3 billion years old. And their metallicity, which is just the amount of heavier elements they contain, is completely uniform. It doesn't change the further out you go. This is a massive clue. It tells us this outer envelope formed super early in the galaxy's history and has essentially been sitting there highly stable and totally undisturbed by major mergers for a very, very long time.
Now you might be wondering, why does looking at all these layers actually matter to us? Well, as researchers like Del Canton and Bernstein have pointed out, observing undisturbed, edge-on disk galaxies like this one provides absolutely vital clues about how different parts of a galaxy evolved together. Because we can neatly separate the young disk from the old halo in Caldwell 72, we can start to decode the fundamental mechanics of how galaxies assemble themselves, and ultimately, that helps us figure out the history of our very own Milky Way.
But remember that double life I mentioned? It is time to pull back the curtain on all that pretty optical starlight. When astronomers switch their instruments to detect neutral hydrogen, which is essentially the raw fuel for making stars, using those sensitive radio observations, the whole serene picture falls apart. The invisible gaseous skeleton of Caldwell 72 isn't calm at all. It's violently distorted, chaotic, and completely stirred up.
When we look at the velocity and kinematic models of this hydrogen gas, instead of a nice, flat, evenly spinning disk, we see extreme streaming motions ripping right along the central bar of the galaxy. And it gets even crazier. At the outer edges, the gas disk is severely warped. It is bending and twisting in these massive, sweeping ways that simply shouldn't happen if this galaxy was just sitting peacefully in empty space.
So what exactly is the evidence of this stirred-up state? Well, first off, there's a massive east-west asymmetry in the gas. On the eastern side, there's this long, drawn-out tail of gas, while the western side hits a really sharp, compressed edge. To an astronomer, this is a dead giveaway that the entire galaxy is experiencing something called violent ram pressure. Basically, imagine Caldwell 72 plowing headfirst through the gas and dust of the Sculptor group, and the friction is literally stripping and dragging its own gas backwards, kind of like your hair blowing in a really strong wind.
Let's move to and see how this builds, because there's another major suspect in this cosmic crime scene. Look at where Caldwell 72 is located compared to its closest galactic neighbor, NGC 300. In cosmic terms, these two are practically rubbing shoulders. They're only about 270 kiloparsecs apart. For context, that's just a third of the distance between our Milky Way and Andromeda. So, that severe warping we were just talking about, it strongly suggests a recent, pretty violent tidal interaction with NGC 300. Their massive gravitational fields have likely been wrestling with each other, physically bending the very structure of Caldwell 72's disk.
But then the radio data threw us one more massive curveball. Where are these completely isolated rogue gas clouds coming from? High-sensitivity observations picked up a whole population of distinct, high-velocity gas clouds hanging completely on their own in deep space, up to 20 kiloparsecs away from the main disk. It's honestly like finding pieces to a jigsaw puzzle scattered halfway across the room.
So the crucial point is, astronomers are still racing to figure out the origin of this rogue gas, and they've got a few leading theories. They could be debris from that violent gravitational wrestling match with NGC 300. Or maybe they're the leftover guts of a smaller satellite galaxy that Caldwell 72 completely shredded and swallowed up. Another fascinating idea is that it's a galactic fountain. Basically, massive supernova explosions in the young disk violently blasted this gas high into the galaxy's halo, and now it's slowly raining back down. And hey, it's also entirely possible some are just an optical illusion, like foreground debris from our own Magellan Extreme photobombing the shot. Whatever the true answer is, it's a stark reminder that galactic evolution is an incredibly messy, violent process.
Which brings us to one final thought. We look at the String of Pearls galaxy and see this gorgeous, serene disk, totally unaware of the violent ram pressures, the gravitational warps, and the rogue clouds surrounding it, until we peer through the radio spectrum. It kind of makes you wonder, as we sit here inside the disk of our own Milky Way, looking up at the calm night sky, what massive, invisible structures and violent gravitational forces might be quietly warping our own home right now? It's a thrilling reminder to always look up with a bit of renewed curiosity, because the universe is always hiding a second face. Thanks so much for joining me for this explainer, and keep exploring.